Thanks, Dan. I was waiting to see the participant numbers stabilize, but they look like they have. Good afternoon, everyone. Let me start by acknowledging that we are on the traditional, ancestral, and unceded territories of the Musqueam people. As a director of IRES, I can say that we have started multiple initiatives in IRES in terms of both engaging and supporting the Musqueam people. Look forward to working with all of you in moving those things forward. Today, we are not in a rush because we have only one speaker. It's my pleasure to introduce Kushank Bajaj, who's been doing his PhD working with me for the last several years. Kushank has a background in earth sciences, and then he was working in the Indian Institute of Tropical Meteorology before he came here to do his PhD. His PhD research, he's in the very final stages of finishing his PhD, so he's working on his very last chapter right now and hopes to submit his thesis in a couple of months. He has been a real pleasure to work with. Kushank is full of ideas, and over the years, we've probably generated 3 or 4 different PhD ideas, but finally he focused on working on what he'll talk about parts of it, but essentially looking at sort of cross-border risks to food systems from climate change. So essentially, a lot of climate change work looks at what's happening within your borders, how does it affect your agriculture. Kushank has been asking, what are our risks from climate shocks outside of the border. With that, I'll hand it over to you, Kushank.
Thanks, Naveen. And thank you all for coming. I'll just share my screen first. Can you all see my screen? Yeah, okay.
It's good.
Awesome. Yeah, thanks all for coming. Today I'll be sharing insights from one of my PhD projects. Broadly, my PhD, as Naveen mentioned, looks at role of food trade in moderating climate risks in food systems. In this one chapter, I'm mapping extreme weather exposure to Canada's fruit and vegetable supply chains at provincial scales. And I look forward to all your questions and comments and feedbacks at the end. As we all know, fruits and vegetables are an essential part of healthy diets. Aligning with the global guidance and all our grandmothers and mothers' guidance, Canada's food guide recommends half of our plates should comprise of fruits and vegetables, excluding starchy roots like potatoes, which is kind of a really sad thing because potatoes are my favorite vegetables. Despite the recognized importance of fruits and vegetables for healthy diets, they currently constitute only a quarter of all available food in Canada. In fact, some studies have estimated that roughly 70 to 80% of Canadians do not consume recommended quantities of fruits and vegetables right now. This indicates sort of a potential gap between dietary recommendations and the actual consumption patterns, which has implications for both public health and food systems. Although Canada is a net exporter in agri-food sector, a substantial portion of Canada's fruit and vegetable demand is fulfilled through international imports. This figure here just shows over time the import dependence of Canada for all fruits and all vegetables. We can see about 80% of all fruits for Canada nationally comes from outside of its borders. This heavy reliance on imports and Canada's large landmass and not so resilient transportation infrastructure exposes supply chains to vulnerabilities arising from both domestic shocks, as witnessed by the 2021 atmospheric rivers that disconnected British Columbia completely from the rest of the country, and cross-border shocks such as droughts in central California's Central Valley. Understanding supply chain vulnerabilities is important and can have implications for both availability and affordability of fruits and vegetables for Canadians. And if you all want to eat more fruits and vegetables, not including potatoes, then caring for resilience of our fruit and vegetable supply chains is of critical importance, and a lot of attention has not been paid to this topic. These vulnerabilities have also made it to national news recently. For instance, cauliflower and lettuce prices increased by 2 to 3 folds in 2015, 2022, and again in 2023. These were mostly related to weather and pest shocks in California. Another example is 30% increase in carrot prices caused by excessive rain in sourcing regions, which happened in 2019. So to assess these vulnerabilities along the supply chains, I conducted two key analyses. First, using provincial scale production and bilateral trade data and demand data, I developed a new data set that maps the flow of fruits and vegetables from both domestic and international sourcing regions to the Canadian provinces. This was done for 18 fruits and 16 vegetables from 2010 to 2022 at an annual scale. Second, I mapped the future extreme weather exposure to all these sourcing regions that Canada depends on. So first, I'll describe how we developed the food flows using this hypothetical graphical illustration because it was a little complex to show it otherwise. We started by gathering the supply data. The bar here shows the hypothetical supply of lettuce to British Columbia from its own domestic production and international sourcing regions. You can see lettuce coming from Mexico and US exporting states like California and Arizona. Both these data sets, the production and trade data, uses a different classification system and thus had to be harmonized to a common classification first. We also validated our harmonization process using national scale supply utilization accounts that Canada reports to United Nations every year. Ideally, one could simply just use this data to estimate provincial scale consumption through a simple food balance approach where consumption equals to production plus net imports. However, despite the availability of this data, it wasn't straightforward to calculate provincial scale consumption or flows. This is for two reasons. First, customs-based data, imports data is based on province of clearance, which is where food commodities enters into Canada through land and seaports and is cleared by customs. This does not necessarily indicate the province of final destination where lettuce is consumed. Second, there's no data set on information on interprovincial flows from province of clearance or production to the province of consumption. So to address these challenges, we employed a mass balance approach and estimated provincial scale consumption and interprovincial flows, as I'll explain in the next few slides. First, we estimated provincial scale consumption, assuming uniform annual dietary preferences across provinces. So this basically means we assume that across all provinces, Canadians eat the same amount of lettuce every year. We also validated this assumption using actual sales data from grocery stores, the scanner sales data, to account for regional preferences. There was just a sensitivity analysis we did in the end. By estimating provincial level consumption under our assumption, we were able to identify any surplus or deficits in supply. For instance, if in this example, BC's consumption that we estimated was 7 million tons, and the total supply was 10 million tons, we calculate an excess supply of approximately 3 million tons for British Columbia. We did this for all provinces, all fruits and vegetables, and all years. This allowed us to pinpoint the supply hubs and hub-dependent provinces across Canada. In our lettuce example, BC, because it has excess supply of consumption, it becomes a supply hub. And Alberta, for an example in this figure, because it has supply and deficit of consumption, it acts as a hub-dependent province. Once we knew that, we started estimating interprovincial flows between them. To do this, we used an inverse distance weighting method. This essentially means the closer the two provinces are, the more significant the interprovincial flows of fruits and vegetables between them. In the final step, we reattributed the interprovincial flows back to their primary sourcing regions, avoiding any double counting. This was done using a probabilistic approach based on supply shares of the province acting as the hub. I won't go super into detail at this point, but if you have any questions, I'll be happy to answer any questions about this. By estimating the flows over time, we were able to identify the provincial supply portfolios and how they change. This animation here shows provinces, the supply portfolios of each province. Each bar represents one province as labeled on the y-axis, and each stack within the bar shows the sourcing region. This is based on the actual data, and you can see USCA stands for California, USAZ stands for Arizona. So you can see how much of lettuce comes from California versus Arizona into BC and how that's changed over time. The x-axis is just simply the supply proportion. Through this data, we were able to identify the flow of 18 fruits and 16 vegetables from every country, every US state, and we were also able to identify any flows between provinces. This map basically shows the aggregated flow of all fruits and vegetables, and the width of the links is based on the quantity of flows. You can see the interprovincial trade between Manitoba and Ontario is massive. That's mostly related to the potato production and interprovincial flow of potatoes. Just a plug here, along with a friend, we are also developing a data mobilization platform. It's going to be this interactive visualization platform where anyone will be able to view these flows and download the data to do whatever they want with it. This is just an example of lettuce. You can see how much, oh, I can't, producer. You can basically see the quantities. You can also see the supply shares of each fruit and vegetable. You can select which fruit you're interested in, and it's going to show you the flows. This is all well and good, but what about the cross-border climate risks? How do we know if Mexico will experience increasing droughts and heat waves, and how this might make our avocado toast more expensive? I believe it's a critical question for some who love avocado toast. So to assess climate extreme exposures in these supply chains, I quantified weather extreme indices using latest global climate simulations. All the analyses was done on Microsoft Planetary Computer. It's a free computing platform complementing Google Earth Engine. I swear this is not a sales pitch for Microsoft, but I think this is really cool. It just gives you access to petaflops of geospatial data, and it gives you access to about 100 cores to do your analyses. This little clip is just going to show you how the animation happened, the analyses happen. So the central purple dot is the user, and you are initially allocated 4 cores, which is what normally a computer has. And as you run your analyses, you basically cut your data, and it allocates your data in 200 cores and does the simulation at the same time for you. So these are the cores popping up. They're doing the analyses for me, and then they're going to send it back to the final user. This just gives you a lot of free computational power. And if you're working with geospatial data, I personally think this is great. So to estimate the weather extreme exposure, I utilized downscale bias corrected data from Climate Impact Lab. They have data available for about 25 global climate models. We selected 9 to address the hot model climate problem in the CMAP6 simulations. And for each model, we estimated 4 extreme agroclimate extreme indices, covering a broad range of temperature and precipitation conditions. For two dry extremes, we estimated the number of consecutive dry days during growing season. For too hot, we estimated the number of days with Tmax above 35 degrees. For too cold, we estimated number of frost dates. And for too wet, we estimated consecutive maximum 5-day rainfall periods. And the way we estimate these is we calculate 30-year average exposure during growing seasons around the year when climate models exceed 3 degree or 1 degree global mean temperatures. By doing that, we can estimate like what the exposure is going to be in a 1 degree warmer world or a 3 degree warmer world. We then create ensemble estimates, which is just to give us some uncertainty estimates around our exposure indices. Finally, we spatially average the 4 extreme indices for each supplying region across the world. The analyses resulted in these 4 global maps for future extreme weather exposure. As we know the sourcing regions from the food flows that we developed, we were able to zoom into key sourcing regions and identify the differential climate exposures across all of these regions. For instance, we find California, Mexico, Brazil are exposed to severe dry spells and heat stress during growing seasons. Canada depends on these regions for over 50% of all the supply of all these fruits and vegetables listed at the bottom. You can see avocados right there. Similarly, we were able to identify risks in key sourcing, flooding risks and frost risks in key sourcing regions as well. We find Mexico and Central America face exposures to flooding, while Eastern Canada, British Columbia, and Washington are predicted to experience more frost dates during growing seasons. So to summarize the exposure throughout the supply chains, we estimated what we call consumption-based exposure. These are estimated as the weighted sum of climate exposure across all sourcing regions by the supply shares. The heat maps here show the consumption-based exposure for some of the most consumed fruits and vegetables, and for all the provinces. The fruits and vegetables are on the y-axis, and the provinces are on the x-axis. What is really interesting about these is we can see the exposure across these different commodities and across provinces. This is one of the sort of power of looking at higher resolutions and looking at provincial scale exposures. For example, watermelon supply for Western Canada is exposed to droughts in Mexico, but we don't see that for the eastern provinces. Similarly, on the other hand, we have like supply of lettuce, which is exposed to droughts in California and Arizona, which almost all the provinces are exposed to that. Similarly, exposure to heat waves in orange supply chains that come from Brazil and California. We also looked at too wet and too cold exposures. Banana supply chain we found was most exposed to heavy rains. This is mostly driven by Costa Rica's exposure to deluge or heavy rain events. Potatoes are also not super safe. There's going to be a lot of frost events happening in Manitoba, which exposes Manitoba's production domestic exposure, basically. We were also able to distinguish the overall consumption-based exposure into domestic and cross-border exposure. So for example, let's take an example of lettuce. We find that 79% of all lettuce coming into Canada comes internationally, and its exposure is a lot more than the domestic exposure. Similarly, we were able to identify blueberries and cranberries cross-border versus domestic exposure, and we find domestic exposure dominates the blueberry, cranberry supply chains right now. There are a number of caveats to mention. First, food flow caveats. We develop food flows using that assumption that I mentioned initially, which is per capita consumption is equal to national per capita consumption is equal to provincial per capita consumption. There is caveats around interprovincial flows decreasing as distance, the inverse distance weighting method we used. In the future, a more optimization approach might improve these estimates. We also do not estimate for loss or waste in our food flows. That's basically because we don't have crop-specific or province-specific loss estimates or waste estimates. There's also caveats around the exposure indices that we used. We used general agroclimatic extreme indices that are not crop-specific. We one can create more crop-specific indices, but this would require crop-specific growing regions, growing seasons, and extreme weather thresholds that are specific to, say, avocados versus bananas. And I think one of the biggest caveat is also we are simply reporting exposure. The overall risk and supply chain would depend on sensitivity of fruits and vegetable production to these extremes, vulnerabilities in the overall food systems, the adaptive capacities, such as changing trade patterns, production systems, and preferences of people. What might be the policy implications of this? The big one that I think is increasing cross-border funding for adaptation and climate resilience programs. Currently, most of the climate finance from Canada, most of the funding goes to mitigation programs. These analyses makes a case for funding more adaptation and resilience programs in low and middle income countries that Canada depends on. We were also able to estimate a few resilience indicators that I haven't shown here, but through that, we find that the supply diversities are pretty low. There's mostly supply is concentrated. We get most of our food, like for example, avocados, we get mostly from Mexico. Over 95% of avocados come from Mexico. So this showing that makes a case for increasing diversity in supply chains and supporting domestic production to enhance resilience of food systems. There's also implications around developing policies, price alleviating policies. And lastly, we just explored one use case of the food flows, which is cross-border climate risks. One could use the food flows to estimate consumption-based impact assessments. One can use it to estimate food miles and GHG emissions, the groundwater depletion that's happening in California due to Canadian consumption, and many other sustainability problems. That's it. Thank you. Special thanks to Naveen, my supervisor, committee members Hadi and Zia, and both current and past Luge Lab members, and also Denise, who is from AFC, who was kind enough to share some of the data that went into this project. I'm happy to take any questions.
Yeah, thank you so much, Kushank. That was great. So as not to overwhelm Kushank, we'll take about 10 minutes of questions, and I'm also not positive that Bonnie allowed the room to stay open beyond that. So yeah, and I'll let Kushank field the questions.
Feel free to unmute yourself and ask any questions or feedback or comments.
I have a question.
Sure. Go ahead, Ian.
I was curious if you're aware of other studies in other countries that are attached to Canada's food trade that are similar or analogous or compatible in any ways to yours that in the future could be merged with this project no more of an international or even more so international scoping kind of project.
That's a great question, Ian. Thanks for that. Most of the work on food flows has been at like international scale. So people just look at national flows. They don't look at subnational analyses. They don't do subnational analyses. There are a few studies in the US who've looked at interstate flows. And there are some studies in deforestation-centered regions which look at subnational estimates. So there is a possible, like one of the future way to expand this work would be to integrate with those subnational flows that people have estimated. So for example, in my data, we can only see flows coming from US states. For example, from Mexico, we just know avocados comes from Mexico, but not from exactly where in Mexico. So that would be one possible way to expand it. But
Cool.
they also
Thank you.
use a lot more complex sort of optimization approach, the work that people have done right now, and they usually look at flows within the country and not across the countries as well.
Interesting. Thanks.
Sorry, Luis. Go ahead.
Hi. Thank you so much for your incredible presentation, Kushank. Like really A+. Amazing research, but also very well presented. I just have a fun question for you. What did you find most surprising, either from the development of your novel methods of analysis or the results?
The most interesting, I think, to me, the most interesting thing was the process of doing this research and the hiccups that come and then the way you move around them. One thing that also came was the interprovincial flows. We didn't know that there was so much of food moves interprovincially this way, and nobody's estimated that before. Specific, like crop specific flows. So that was really interesting.
Great, thanks. I can't wait to explore the globe with the flows that you're making accessible.
Thanks.
I have a question. Oh, sorry, Milind.
Milind.
Go ahead, Josephine. I can wait.
I have a question about the adaptability point that you made at the end, because I was wondering about that. Like, basically, when you were talking about extreme weather events, I was wondering whether it was interesting to distinguish an event in one place versus events that occur in multiple places and prevent you from switching to another, importing from another production area, for example. Is it something that you could actually look into with your data, like looking at reactions to some event? I haven't thought about whether you have the granularity to actually establish a little bit those changes in flows as a function of in reaction to events.
Can I share my slide? I think there are some. There's one I saw for which is oh, sorry. There was one that I noticed for avocados, which was not related to a climate event, but this was related to a policy event where US just blocked all the imports coming into from Mexico to the US. And you can see the portfolios basically change. So it was roughly about a little less than 70% of all avocados used to come from Mexico, and some used to come from California early in 2010s. And then Mexico just basically expanded and took over 95% of all supply. And when that event happened, you could see it completely switch back. The total quantity is reduced as well, but we could also see the portfolios change where a lot more avocados were coming from California that year. Milind.
You knew this was coming, right, Kushank? So people don't shop. I don't go in and say, I'm going to buy some oranges. I go in and I say, I want to buy some fruit, right? Then I might pick some apples, maybe some kiwis. And if the oranges don't look great or they're too expensive, I'll do something else, right? So how does that how far is your analysis from that kind of behavioral element of this? So, and is there any way you can create baskets from the data you have, and then to look at vulnerability of baskets where then, these are baskets would be things that you can substitute for each other? Thanks.
Thanks, Milind. That's a great question. There's definitely the substitution thing where people can easily switch between apples and oranges, for example. But the thing is, every fruit and vegetable supply chain is so specialized. For example, oranges. Oranges demand is mostly, a lot of it goes into orange concentrate, which goes into converts into juice. So you know that's not going to be switched. You know there's going to still be a solid demand of orange juice. There's some that can be switched, and I think that's a great suggestion that I could try and group them and show if the exposure is the same across those substitutable produce. Like onions, for example, you can't, if you're an Indian, you can't cook without onions. There's no substitute. Same goes with tomatoes.
But you can buy frozen onions, or at least you can in France. I don't know if you can buy frozen onions here.
I don't know if I would try that, but sure. You can buy tin tomatoes. So that's a big one where you have that option. I hope I answered your question.
That was an open question. Thanks.
Juan? Go ahead, Juan.
Sorry, my computer was a bit slow on reaction. Can you hear me?
Yep.
So thanks. First of all, amazing presentation, Kushank. It's great to see just the final results of your work. Really excited. I'm also surprised either because we thought similarly at the beginning or after having Melinda as a committee member, my question was fairly similar. So I'll try to build upon that. I also feel like if I go to the supermarket and something is too pricey, then I just won't get it. But I know within my household, there's some people that they say, you know, I want to eat that. Like I'm going to treat myself. So I just wonder whether you kind of explored a bit how responsive the consumer is to these price shifts versus further up the supply chain. So I'm imagining, because supply chains are like more established and like there's a lot into it, they just go through with it. Like they'll just keep purchasing, assuming that the demand's gonna be there. But I wonder, like once prices spike to the extent that they do at the supermarket, for the example of the lettuce that you gave, do people actually buy the $8 a head lettuce? Like, or it does that end up just like going to waste at the supermarket? Is there a way to capture the impact of these price increases on potential increased kind of spoilage at the final stage, just because people are not willing to pay that extra price?
Yeah, again, that great question. I think there's a lot of work economists have done on demand elasticities of these produce as well. I'm not sure how to do that from this data, but it's one of the big caveats that goes into the discussion section as well. On a slightly different note, we also looked at the impact of these shocks on prices, which can get a sense of how affordable these produce get. Like how does a cross-border shock, for example, a shock in California affects lettuce prices here. So we've done that as another chapter of my thesis, but not so much on the demand dynamics.
Yeah, that's great. I know the question was kind of more on the speculative side and probably something you could look at after, but yeah.
Yeah. There's also this one more thing I just want to say is, again, the specialization of these supply chains and the different users. For lettuce, for example, the food services, they're going to grab up all the lettuce. Doesn't matter if it's $8 or $10, because you got to give that to McDonald's and KFC. It's too much at risk. So you'll have that constant demand for lettuce, for example, from that supply chain, which is very different than us buying it from a grocery store. And other economists have also looked at scanner data and found that fruit and vegetable prices are a lot rigid in North America, at least, where big grocers don't change their prices as often because it costs them a lot of money to go change the tags, but also because they want their users, consumers. So they don't want the customers to go into somewhere else. So, but they don't switch prices a lot.
Excellent, thanks.
I'm sorry, I'm not monitoring the chat here. But if anybody has a question, please.
Not so many questions, but lots of interesting discussion.
Thanks, man.
One second to see if anyone has a final question, and then not.
I have one more question, if that's all right.
Yeah. Very
I know it's another kind of just opening to discussion question, but curious if when looking at all this data, if there's an obvious way to incorporate carbon tracking through this, or is that kind of already been taken care of by a lot of other studies? I know that carbon has been in the conversation for a long time, but it would be curious to investigate individual like by product carbon emissions, especially when you're talking about potentially food coming into British Columbia and being shipped elsewhere instead of being directly going into other provinces. Was there at all in these data sets like carbon information already attached to some of them, or are you talking about really would it be a lot of work for somebody to take this study and then run with it into the carbon direction or diversify it?
I think it would be an easy thing to do to move into the carbon direction. There's only one study in Canada that looked at food miles from 2000 in fruits and vegetables. That was from 2007 or 11, I can't remember. But there was a big issue with that study. They don't estimate interprovincial flows. They didn't solve that problem of the province of clearance, the imports being province of clearance and not consumption. So they looked at GHG. You can look at carbon from GHG emissions related to food miles, and that could be relatively an easy next thing to do with this data set.
Very interesting. Yeah, it surprised me when you said that these provinces of clearance are tend not to be or tend to be only responsible for like 70% of consumption within of those vegetables. Very interesting.
Thanks, Ian.
All right. Thank you, everyone. And thank you so much, Kushank. That was an amazing presentation. I'm excited for when the tool becomes completely available and we can apply it to all sorts of supply chain economics applications or social vulnerability studies and things like that nature. So thanks, everyone, for again. See you shortly. Enjoy the rest of the snowy day.
Bye, everyone.